Hi, thanks for joining us. My name is Jared Rosoff. I'm the Director of Product Marketing for Tengen, and today we're going to be talking about writing apps for Cloud Foundry using MongoDB and Spring. I'm going to begin the webinar by giving a brief introduction to MongoDB, and then I'm going to hand over to Thomas Risberg, who works on the Spring team, and he's going to cover Cloud Foundry and how you can use it inside the Spring data framework. So let's start off with MongoDB. So MongoDB is a high-performance, document-oriented, horizontally scalable database. It is designed to be extremely scalable, to work well in cloud environments, just like Cloud Foundry, and it's designed to better match the modern object-oriented development practices that we use today. The traditional relational databases have been around for a very long time, and they present some challenges with things like complex object relational mapping frameworks, and we find that they don't map very well to our modern practices. So MongoDB is designed to be a very agile database to support a much richer data model than we're used to in a relational world, and it's designed to work very well with things like Spring and Cloud Foundry. So I'm going to go through a couple of the features of MongoDB and how we typically use MongoDB to model and access our data. So unlike a relational database where we store data in tables, MongoDB stores data as documents. Now, we actually use JSON documents as the native format of MongoDB, and this means that has a couple implications on how we model our data. First of all, it means that our data schema is completely dynamic. We can add new fields and columns to our data store at runtime without needing to tell the database about it. Secondly, we can store richer data models inside of a document that are more complex to manage and model in a relational schema. Things like one-to-many relationships, lists and arrays, and nested objects can be stored directly inside of a single object in the database. This often cuts down dramatically on the time we spend modeling our schema and makes it a lot easier to map sort of native Java code and objects into the database. And then MongoDB is designed to work really well with that data and support all the kinds of features you're used to from a relational database like indexing and queries. So we'll go through sort of how we use MongoDB. These examples are shown from using the MongoDB Shell, and they're designed to sort of give you a quick introduction to the database itself. Following this brief introduction, Thomas is going to show you how to actually access this from Spring Data Framework. But this hopefully will give you a good primer on what's going on behind the scenes inside your database. So all these examples are actually written in JavaScript, which is the native language of the shell in MongoDB. And you can actually cut and paste all these examples from these slides into your MongoDB shell and see them working for yourself. So in this example, we're creating a document. We have a simple blog post, for example. We have an author that was written by Roger. It has a date. And we're using the date constructor to actually ask the database to allocate the current timestamp when this record is created in the database. We have a text field that stores the actual database post, and then we're storing an array of tags. Then we say db.post.save, and we pass it that document we just created. What this does is this actually creates a new collection in the database and stores this document to that collection. What's notable here is the things that I didn't do. I did not tell the database that I had a post collection. Simply by mentioning it for the first time causes it to create that collection. I also didn't tell the database anything about the schema for this collection. I didn't need to tell it that blog posts have an author or a date or text. Simply by using those fields inside the document, the database is totally fine storing those things inside of our collection. So once we've stored our blog post into the database, it's very easy to go and query it. MongoDB does not support SQL, but it does support a very similar query language that makes it easy to go query the database. So if I type in the command db.post.find, that's the equivalent in the SQL world of select star from posts. Now, we've only inserted a single document into our database, so we just get one record back when we do this find. Now, you'll see that the document has changed slightly since we inserted it. The notable changes are, first of all, we've allocated an _ID field. This is like a primary key for the documents inside of your MongoDB database. they're actually stored as a globally unique identifier, and if you don't specify one yourself, it'll be allocated by the database. You can override that value if you want to pass your own unique value as the primary key. That's totally fine. The most common practice, though, is to just use the built-in object ID that's stored by the database itself. You'll also notice that the date field, which we passed as a constructor in the initial document, has been expanded to a string of the current date. Well, actually, I guess that's not the current date. It's about a year ago, but we'll ignore that for the moment. So the view there of a string, that's actually a helper in the shell. Internally, MongoDB stores that date as a timestamp and an offset, sort of like a Unix timestamp type integer. The shell is helping us out here and rendering that as a string so it's easier to read. Now, once we create documents inside the database, we can define indexes on them, just like you can in a relational database. So I can say things like db.post.ensureIndex author:1. What that does is that creates a B-tree index on the author field, and that enables me to do queries like db.post.find author:Roger and have those queries work quickly. Now, if you're coming from a SQL background, that query, db.post.find author:Roger, is the equivalent of select star from posts where author equals Roger. So MongoDB lets you query on the attributes inside of your documents, and this is going to work a lot like a relational database. And just like a relational database where you define indexes to make your queries fast, we have the same kind of capabilities inside of MongoDB. So you don't need an index to make a query. If I query on a field that's not in the index, it's going to do the equivalent of a table scan, which obviously in a relational database might be fine, or it might be slow, depending on the size of your data and the frequency of the query and exactly what you're trying to do. But a general rule of thumb is that you want to create indexes to support the queries that your application is going to do. Now, MongoDB's query language is pretty rich. We have a number of query operators you can use inside of queries to do things like range queries, to check the type of fields, and to do more complex things. So, some of the query operators we support are, the all field, which, matches arrays that contain a number of values. The exists field, which lets me test whether or not a field exists in a document. And you see that in the first example here, db.post.find where tags exist true. So this tells the query processor to go find me all the blog posts that have a tags attribute in the document. Now, since MongoDB has a completely dynamic schema, I may have, say, 1 million blog posts, but only 20,000 of them have tags associated with them. So this query would allow me to go find only those posts that have tags on them. The second example, finding the posts that match a regular expression, I can say db.post.find author and then a regular expression. Now the caret there is anchoring that regular expression to the front of the string. ROG is matching the string ROG, and the star says I don't care what happens after that. The I after the regular expression is saying that this is case insensitive. That query will use an index if you're anchored to the front of the string. If it's not anchored to the front of the string, it's going to need to do a table scan because there's not an efficient way to do that. But this is obviously a very powerful capability to do sort of the equivalent of like queries in a relational database on your Mongo data. We also support aggregation in those queries. So the final example, db.post.find author:Roger.count. What this is doing is this is actually returning the number of documents inside the post collection that were written by Roger. We support a number of aggregation commands like count, group by, and we even have built-in MapReduce capability in the database. And all of these work with the full query language. So I can, in the query expression in any of these operations here, I can use multiple attributes. I can do range queries, say, find me all the posts posted between a year ago and today, for example, or find me all the posts written by Roger or written by Thomas. Now, MongoDB, being a document-oriented database and part of the NoSQL movement, one of the things that we aim for in MongoDB is to support very high scalability. Now, in order to scale a database horizontally, one of the things you give up is the ability to do complex transactions. And this is true of virtually all of the NoSQL databases. But what MongoDB does to sort of make up for this is it gives you a strong ability to perform atomic transactions on an individual document. Now, what this means is that I can go and atomically modify a document without having to read that document out, modify it, and then put it back. Right? So there are a number of update operators listed here, things like set, unset, increment, push, pull, that allow me to modify a document in place. So in the example here, what I'm doing is I'm creating a comment, right? So Fred wants to comment on a blog post. There's a particular date when he added his comment, and there's the text of that comment. And then this command, db.post.update, ID equals ... I'm sorry, I didn't write out the full object ID on this slide, but this is the first part of this query is sort of like the where clause in my update. This is specifying which document I want to update. In the second line of the command, I'm using the push operator to say I want to push this new comment I wrote onto the comments array of that document. Now what I'm really doing is I'm sending this command to the database, and it's going to atomically find that document with that ID that I specified in my query, take the comments field that I passed in the update, and append it to the comments array in that document. If the comments array doesn't already exist, it will be created as part of this command. If it does exist, then the comment is going to be added onto the back of the array. Now we can see the results following our update. So now our blog post document now has a comments array. That is an array type. And inside of that array, we have a nested document that is the comment that we passed in that command. Now this command is totally atomic. There's no point in time where you'll see this document being partially updated. The entire update happens atomically and isolated from any other queries or transactions going on inside of the database. And this tends to be a pretty powerful tool to be able to perform strongly consistent atomic updates to rich documents inside of your database. Now, with this complex data model, MongoDB can do a bunch of tricks particularly with things like indexing that are quite powerful. So, for example, I can index nested documents. So in our previous slide, we had, in our blog post, we had an array of comments. And inside the comments array, I had nested documents, each of which had an author. Now, there was currently only a single element in that array, but you can imagine there being hundreds of comments on a single blog post. So if I say db.post.ensureIndex comments.author, what I'm doing is I'm telling the database to create an index on all of the author values inside of the comments field on all of the blog posts. So if I had 100 blog posts and each blog post had 100 comments, all of those authors would be stored in the index, and that would allow me to do a query like db.post.find where comments.author is Fred. And what that query is going to do is that's going to go find me all of the blog posts that Fred added a comment on. So this is obviously a pretty cool trick for indexing complex data models. I can also index on array values. So, for example, we had a tag key in our blog post. So if I say db.post.ensureIndex on tags:1, MongoDB is smart enough to know that with that array value, what it should do is it should go and take each value in the array and add that value into the index pointed to the outer document. So this allows me to do things like db.post.find tags:tech. What this is going to do is it's going to find me every post that had the tech tag in that tags array. Now, the tags array had multiple fields inside of it, right? So what this is doing is it's actually searching on the individual values inside of that array field. If you were to try to model this in a relational database, you would need to have multiple tables. So I'd have, like, for example, I might have a blog post table, and then I might separately have a tags table, and I would need to have a row in the tags table for each individual tag and a foreign key pointing to the post. And then I might, index on that tags table and do a search that way. With MongoDB, we find that the query to do that kind of index and that kind of query to be a far simpler and easier syntax. We also support geospatial indexes. So you can actually index on XY coordinates. So if I do like db.post.ensureIndex author.location and I specify 2D as the index type, what I'm actually doing is creating a geospatial index. One of MongoDB's early adopters was Foursquare, and actually Foursquare uses MongoDB to store all of their data inside the Foursquare service. And they use geospatial indexing to do all of the check-ins and location queries. So every time you check into Foursquare or check to see whether any of your friends are nearby, that's using a geospatial index inside of MongoDB to find all the people near your current location. What this means is that basically MongoDB gives you this database that allows you to model data in very complex ways. And it tends to map much more closely to how we think about our data models in code. When I'm building my Java object model, I tend to have a much more compact representation of my data model than I might have in a relational schema. I have like a Java class that represents some thing or an entity. I might use arrays or tree map data structures inside of that object to store associations to other objects. And MongoDB works kind of the same way. I have a notion of an entity that can have one-to-many relationships, that can own nested objects, and all of these things can be represented inside of a single document. Right. This rich document capability, we can index it, we can search it, and store it, and perform atomic transactions and updates on that data natively in the database. So it tends to be a very powerful and agile tool for modeling data and for running in services like Cloud Foundry and Spring. With that, I'm going to hand over to Thomas, who's going to talk about Cloud Foundry, which is a platform that runs MongoDB, and how you can use Cloud Foundry and Spring to build applications using MongoDB. Thomas?
Thank you, Jared. It was a great introduction to MongoDB, and we'll now move on to the second part and the third part of our presentation, Cloud Foundry and the Spring Data support for MongoDB. So let's just first cover quickly what is Cloud Foundry. So Cloud Foundry is platform as a service. And what does that mean to me as a developer? Well, it means that I don't have to worry about installing application servers and database servers and other types of infrastructure. I just write my application and deploy it to this platform as a service. And it's basically a self-service type of interaction. I depend on Cloud Foundry to provide the software stack and the execution engine for my applications. And there are tools that I can deploy my applications. I can provision databases and other services and tie them to my application. And I can update my application. I can add additional instances to scale my application, and any type of upgrades for the web application server or database servers are taken care of by the provider of this platform as a service. So that makes my life as a developer a lot easier. And with Cloud Foundry, I have a choice of frameworks. Right now on cloudfoundry.com, I can develop using Java, either Spring application or Rails applications. I can also develop in Scala using Lift. And we have great support for Ruby with Rails and Sinatra. And the last one we right now support is Node.js. There are other partners that provide PHP and also Python, and they're running Cloud Foundry, but they are hosting, the partner is actually hosting that service. And that's not available right now at Cloud Foundry. And Cloud Foundry is an open source platform, by the way, so anybody can just download the code and create their own service if anybody wants to do that. You can do that on your own laptop, or you can provide that as a service. And in addition to these application frameworks, we also have application services that we provide. So you can provision a database, either MySQL or Postgres. You can provision MongoDB, which is what we'll be looking at more in the rest of this presentation. You want a message service? Well, right now we have RabbitMQ available. If you need a key value store, Redis is available right now. And as time goes on, we'll add more and more of these application services. So what does the cloud provider interface provide? It lets you run this Cloud Foundry in many different ways. You have the microclouds, which is basically a local version of Cloud Foundry that you can run on your laptop. Right now you can either download it, or we also have USB sticks that has a virtual machine on them that you can start up using a VMware software and run your own virtual machine on your laptop and develop against that. There are public clouds. CloudFoundry.com is what we're looking at today. Like I mentioned, some of the partners are running their own public clouds. And coming soon, you'll be able to install a private cloud in your company's data center if you choose to do that. So in terms of getting access to CloudFoundry.com, you first of all need to go there and sign up for an account. And once you get your credentials, you can actually access the service. And you start by installing a client, which is called VMC, which is a Ruby application. So you use gem install to install that. And once that's installed, you can say, I want to target the api.cloudfoundry.com as the server I'm talking to right now using the VMC target command. And then once you target to your cloudfoundry.com instance, you can now log in using your credentials, which is your email address that you signed up with. And you also have a password, so you need to authenticate. And once you're logged in, you can do a VMC info, which will show you where you're connected to, or what credentials you're using, and how much memory you have used up so far, how many services and apps you have. So that's the basic information you need to get started. Now moving on, we'll look at, we might want to see what runtimes are available. So depending on where you connect to, there might be different runtimes available. If you connect to one of the partner clouds, then you might see PHP or Python show up here. But for the CloudFoundry.com, you'll see Node, you see Java, and you'll see Ruby 1.8 and 1.9 being available. And if you do a VMC frameworks, you'll see what frameworks are available, like Spring, Node, Java Web, Rails 3, Sinatra, Grails, and Lift. Those are the currently supported frameworks. And let's move over to the services. This is where MongoDB comes in. That is one of the supported system services. So MongoDB, MySQL, Postgres, RabbitMQ, and Redis are the currently supported services. And when you do VMC services, you also see what services you have provisioned as a developer. And you can see here I have two services provisioned. One is Mongo Bookshelf, and the other one is Mongo Rails, which I have hooked up to a Rails application. And they're both MongoDB instances. So how do I provision a service? Well, again, you use the VMC command, and you say VMC create service, and you tell them what type of service. This time it's MongoDB. And then I can optionally give it a name. If I don't give it a name, it will be assigned a generic name. But I have a bookshelf application that I'm using as a sample here, so I name this Mongo Bookshelf. And if I do a VMC services, again, it lists all my available services here. And the new feature that's outlined in a blog post on the blog.cloudfoundry.com recently is this new tunneling into the data service that we create on Cloud Foundry. It used to be that you weren't able to actually connect to the database there because it's running protected in the Cloud Foundry environment. But we now have an application that lets you tunnel into this protected environment that you can actually access your database from your client desktop. So you need to install a pre-release of the VMC gem for this to work, and that's all outlined in that blog post. So I have that installed here, and I VMC tunnel into my Mongo Bookshelf database. And it starts up this tunneling application, and it shows the information I need to connect, which is a username and password, which are all generated by Cloud Foundry. And also the database name is DB. So I can either choose to use the Mongo command line client, or I can use another client that I have installed on my desktop. In that case, I can say none, and then I have to use these username, password, credentials to log into the database. But I picked the Mongo client here, the command line client, so this VMC command automatically starts that up for me, and I end up in the MongoDB shell, and I can issue commands here like I do with show collections. And since I just provisioned this database, there's really nothing in it. It's just the system indexes and system users, which are always available in the Mongo database. But this is a great way to put in initial load of data, or you can export the data if you want to create a backup or something. So this is a very good way of interacting with your database that's hosted on Cloud Foundry. So in terms of deploying applications, how would I do that? Well, you use a VMC command again, and you use the VMC push, and you tell them the name of your application. And if I'm writing a Java application, use Maven, then the WAR file I'm creating ends up in the target directory. So I have to specify a path target so the VMC command can actually find the WAR file. And it inspects what you're trying to push, and it says, okay, the first thing it asks you, is this the URL you want to use? And I say, yes, that's fine. Because I know there's probably no other Mongodb Shell application running. Now, this is a global namespace, so it's possible that you'll get a message saying that this URL is already taken, and then you have to choose another URL. And it will also inspect what you're pushing and say, okay, this looks like a Spring application. Is this correct? And you can say yes or no. I picked the default yes here, and I also picked the default 512 meg for the memory allocation. So now it creates the application, and then the next question you get is, would you like to bind any services? And since this is a Mongo application, I say yes. I want to create a service. Actually, we just created one on the previous slide, so I'll use the existing provisioned service. And it lists everything I have available. And I say, okay, Mongodb Shell is the one I want. So I say, okay, please select one. And it binds that service to my application, uploads all the application bits. And as you can see, it's only uploading 40K, which means that big part of all the jar files that are included in my WAR file already exists up in Cloud Foundry, so there's really no need to ship all the Spring jars and all the Hibernate jars or Mongo jars or whatever jars you're using. There's no point shipping them up over and over again. So if they already exist up in the cache on Cloud Foundry, they're not going to be transmitted again. This just speeds up your application deployment. So then hopefully you'll get the okay that the application starts okay. And we'll look at the sample application, and we'll look at more other ways of deploying it using a Spring Source tool suite in a little while. So I mentioned earlier that you can scale your applications by increasing the number of instances you're running. So the command for using that is VMC instances, and you give them the name of your application and how many instances you want to run. So if we set it to 2, then next time I do VMC apps, it will show my Mongodb Shell running with 2 instances. So this is a good way of scaling your application. You just have to remember that each instance will take up memory of your allocated 2 gigabytes. So let's switch over briefly to the Spring Data project, which is where we support the MongoDB when you're writing Spring applications. So Spring Data is about providing the classic Spring value propositions to NoSQL databases, like productivity, the programming model consistency, and everything. If you're used to writing with a relational database, you're using JDBC template, you'll be instantly familiar with the Mongo template. And we're supporting a number of NoSQL databases like Neo4j, Redis, React, and MongoDB, and we're also adding support for Hadoop and Gemfire. And in addition to the NoSQL databases, we're now adding support in JDBC for some extensions, like support for Query DSL. And we're also adding some JPA support for repositories, where similar to what you do in Grails or Rails, you can have named query methods so that you don't have to write the code behind it. You just provide an interface. And the JPA repository project will actually build the implementation. So you just specify find by last name but you don't have to provide the actual query or how to do that, the implementation to pulling that data out. The JPA repository implementation will actually build the implementation that's needed for running that query. We're not going to cover that in this talk. I just want to mention that it's available in there as well. So for the MongoDB support, we have the Mongo template, which I mentioned is very similar to the JDBC template. It does a couple of things that the JDBC template doesn't do. It does automatically map your POJOs to Mongo documents. And you can control the mapping by providing annotations. Like we have a document annotations that you can say, okay, this POJO is a document that I want to store in Mongo. You can provide an ID to identify the ID field. And you can use dbrefs, which is a Mongo way of referencing a document that's not embedded in your document. It's actually a separate document. Like in my example, I have books and authors. So the book has a reference to the author, but the author is actually a totally separate document. It's stored in a separate collection. And the mapping Mongo converter is used by the template to provide this mapping support, and it uses the Spring's conversion services under the hood. So if you have specific needs, you can provide your own converters, and you can register them with a mapping converter and have them provide the mapping instead of relying on the built-in mapping. And the exception translation will actually translate any Mongo exceptions to a corresponding Spring data access exception, very similar, again, to the JDBC support, where we translate all the SQL exceptions into Spring data access exceptions. And we also have a Java-based query criteria and update DSLs to make it easier to build the document, the query document that you saw Jared showed you earlier in the talk here. Instead of actually typing out these JSON strings, this Java-based DSL will actually let you use regular Java methods to build up these queries and the update documents. And similar to the JPA repository, we also have an implementation that provides similar support for Mongo. It shares a lot of code with the Spring Data JPA repository support, and it also integrates with the query DSL. It's an independent project, but it's very interesting, and it gives you access to type-safe queries. So you don't have to provide strings anymore for the field names, which makes it much easier if you want to refactor your code down the road. So we're working with POJOs. You have annotations. I already mentioned the document that it identifies the domain object to be saved as a MongoDB document. The ID annotation identifies a field. There's a field annotation where you can specify the order that you want your fields to be placed in the document. And you can also change the name of the key used in the document for the field name. It defaults to your field name, but if you want to have some other name, you can specify that as well. And again, the dbref is if you want to have a separate document instead of an embedded document. So let me see. It's Crud methods. You insert an object, and there's a save object. They basically do the same thing, except that the insert requires that the object, the POJO you're inserting, the corresponding document does not exist in the database yet. So it will check, and if it's there, based on the key or the ID, it will say, okay, you can't insert it, but you can save it, because the save will do both an insert and an update depending on whether the document exists in the database or not. And their update first and the update multi will basically do the same thing. You provide a query to select the documents you want to match on. You provide an update document that specifies whether you want to increment a field, you want to push a comment into a blog post, and then you also specify the entity class you're working with, because we use that to determine what collection you're actually going against. And update first will just update the first document that matches that query. Update multi will update all the documents that matches the query. And you can also remove objects. So you say, we use the ID to find the object, and it's removed. And going over to the finders, you can find by ID. So you just pass in the ID of the entity class. You can pass in a complex query, and then you can say find one, which will just give you back the first results, or you can just say find, which will run the query and build a list of all the documents that match that query and convert them into the POJO class instances and give that back in the list. And you can also say find all for this class. So we'll take the class, figure out, okay, that's the book collection, that's the author's collection, and we'll retrieve every document in that collection and map them to the document, to the entity class, and create a list of all the results and hand that back. And in terms of working with queries, we can see a couple of examples here. We build a criteria, and we say where published, which is the published date, is greater than or equal on the date that we're actually querying it on. And this will create a criteria, and then we can add to that criteria. We can say, and categories are in a set of categories that we want to match against. So if we're searching for a book, we can say, okay, it has to be published after 1/1/2008, and it has to be a book that's whose category is in either Java or Spring or Mongo, or whatever categories I want to search on. And then once we have our criteria built, we create a query, and we say new query and passing in this search criteria, and that creates the query that we can pass into Mongo templates finder method. And we say, okay, we're searching for a book, so we provide the book class as the resulting type that we want back. So then the Mongo template takes this query, creates a query document out of that, sends it over to Mongo database. Mongo will create a cursor against all the book documents that it finds, and then Mongo template will take all those documents and map them into the book class and create a list and hand that back to whoever called this method. And to get all this to work, you need to configure your application using either the namespace support, or if you want to do Java config. In this example, I only have the XML using the namespace support, but there are other examples online that shows how to do this with a Java config style configuration. So basically, you need to create a database factory, and so the MongoDB namespace is defined up here, and then we use the MongoDB factory entry here, providing the host and the port and the name of the database. So in this example, the host is a local host, and the port is the default port for MongoDB. And I'm using a database called DB. And then once I have this DB factory created, I can hand that into the Mongo template as a constructor argument right here. So its name is DB factory, and just references the DB factory I created using the MongoDB factory entry. And that's really all there is to this configuration for this little sample app that I have. Let me show you this. Here's a link for the Mongo template example app that I have. It's up on my GitHub account, Risberg/webinar-Mongo template. So once you download that, you can play around with it and see all these different configuration options that we're using. Just want to go back to this specific support we have for Cloud Foundry when we develop Spring applications. There's a namespace called Cloud Foundry Runtime. So if you're using Maven, this is the dependency you have to include to have that part of your application. So it's called Cloud Foundry Runtime. The current version is 0.8.1. And it's in the Spring Framework milestone repository. So if you don't already have this in your PARM file, you need to add this repository to pull this in. And then you can just say, instead of using the MongoDB factory, you can say Cloud MongoDB factory using the cloud namespace. And all you really need to specify here is the ID. The right concern is optional, and so are the Cloud Mongo options. They're also optional. They're only there if you want to provide specific configuration options. But again, for most of the examples I just use the defaults, which run fine. So let's take a quick look at this demo application. It's a bookshelf application. So here I have a couple of sample books I added in. Hopefully you can see that now. There's a way to edit books, to add books, basically a title, author, ISBN, price, and the published date, and then the categories that this book covers. And if I want to search for books, I can specify I want to search for all the Java books, and the Java books should show up. I can search for all the Mongo books, and we should get some Mongo books to show up. Or I can search for Java and Mongo, and we get all those books combined. And now I can also say I want everything that's published after 2010, and we get a smaller list of books showing up there. So this is how all these are just used to build up the search criteria I showed you in a couple of slides ago. So how do I actually work with this application? So let me pull up Spring Source Tool Suite, which is I used to develop this application. It's basically a Spring MVC template project from Spring Source Tool Suite that I used, and I just modify it to use MongoDB and also to use Spring 3.1 instead of the standard 3.0. So I'm using 3.10 RC2. I'm using Spring Data Mongo version 10.m5, which is milestone 5, which is the current release. And I also use Cloud Foundry 0.8.1, the runtime version for that. So I add these extra dependencies to my POM here. Here's the Cloud Foundry entry. Here's my Spring Data entry, which is just Spring Data MongoDB. And the rest are just standard Spring dependencies that were created by the template project. And here's the example of my root context, which has all my customizations. So it's the Mongo template. We already looked at that a couple of slides ago. I have my MongoDB factory using the Mongo namespace when I run locally. And I have the Cloud MongoDB factory when I run in the cloud. Now looking at this, you see the Beans profile, which is a new feature in Spring 3.1. It lets me define different type profiles depending on where my application is running. So the default here will run against my local database. And if I'm running in the cloud, since I'm using the Cloud Foundry runtime in my application, it will automatically detect that I'm running my application in Cloud Foundry, and it will actually enable the cloud profile at that point. And that means that this is the bean that will be active when my applications run, rather than the default bean that would be active if I ran this locally. So this is a very convenient way of having different beans for different environments. And it gives me great control over how to configure all these services. In this case, I only define the Mongo database service, but if I had like a Redis or a RabbitMQ service as well, then I would include them here in the default and the cloud profiles. So let's take a quick look at the author class. I have annotated that with document. The string, I have a string representing the ID. You saw earlier that Jared showed you that you'll get an object ID generated if you don't provide an ID, which is what we're relying on here. So we just map that generated generated object ID into a string, because most Spring developers are more used to working with strings or longs or whatever for their object IDs, and they don't want to rely on maybe the Mongo class for their domain objects. Of course, they could. You can easily use an object ID from the Mongo support as well if you want to do that. It's really up to the developer to choose. So let's take a look at the book class. It has the title, has an author. We see here the author is a DB ref. So that means that the author will be stored as a separate document. It will not be embedded in the book document. We have specified here, we have our own string ISBN. Instead of relying on the object ID that gets generated, we're actually providing an ID in this case. And then we have date published and the price, and the date published we want to index. So I specify this is indexed, and then the the Mongo template will automatically make sure that this class is indexed, or that this field is indexed, so we can speed up searches. And you also have a set of categories that this book covers, so there will be Java, Spring, MongoDB, whatever. And the rest is just getters and setters. So I have this interface that defines how I want to interact with my database. So let's open up the implementation here. I have the repository annotation on it to get the exception translation. I have the Mongo template auto-wired in here. And then I can do an insert using the Mongo template. I can do a save. I can do a find, creating a new query using a criteria where ISBN is and the passed in ISBN value. And then I do Mongo templates, find one based on this query, and I want the books back, so I do a book class. And I only find one, so I can return the book that's returned by the Mongo templates right there. If I want to remove, same thing, I build a query that's passed into the Mongo template, and I specify book class here because I want to make sure that it goes against the collection that the books are stored in. I can do a find all, which will just basically run a query or ask MongoDB for all the documents in a certain collection, which is, again, specified by passing in the book class here. And then I just return an unmodifiable list of all those books. Now, the find by categories or year is a little more complex, but I basically build up a query here. So I say, I create a search criteria, and then I just put in where published is greater than or equal start date. And if they specify categories, I just add that into that criteria where categories are in, and the set of categories that I provided. So if I said Java and Spring, then the categories had to be in one of those specified values. And then I create a query based on this search criteria, and that's, again, passed into the find method together with the class, so I know what type of objects I want back and what collection to go to run the query against. And then there's one method to look up authors. So if you add a new book and the author already exists, we don't want two entries for each author. So this just looks up the author by the name, and if they already exist, we use the existing DB reference, or if they don't exist, we'll create a new entry there. So that's a very quick review of this sample application. Like I said, you can download this from my GitHub account, trisberg/webinar-mongo-template. Just want to show one more thing here before we go to the questions. Spring Source Tool Suite has this VMware Cloud Foundry support built in, so you can see all the applications I have deployed here. And here's my Mongo bookshelf. It's running. I can modify my application and redeploy it from within my IDE here. I can create new services, like add a new database and bind that to my application easily from within the IDE as well. I can stop my applications here. And so now this application is stopped. So if I go here, I should really not get anything back here, right? So I get destination not found. So then I can start it up again. And hopefully we'll see our screen here again. So this is a quick tour of the Spring Data support for MongoDB and how to run that in Cloud Foundry. And we're now ready for questions. Okay, so we have a question here. Is the Cloud Foundry support Java application server? And yes, it's currently the Java application server is Tomcat 6, and we're looking at upgrading that to Tomcat 7 soon. But right now it's Tomcat 6 that it's running. And yes, there's a question here if it has support for Grails. Yes, you can deploy Grails applications to Cloud Foundry. And it also supports a RU application. So if you're a Spring developer, yes, you can use Grails, RU, or just traditional Spring Framework applications. And you can also deploy standard Java web applications as well. And is there MongoDB GORM support? Yes, there is. The Grails project has been very active in the NoSQL space, and they have great support for MongoDB plus Redis and other NoSQL databases. So I would say that they're actually a step ahead of the Spring Data project when it comes to supporting NoSQL databases. So there's a question, how to map inheritance with MongoDB Docs. Maybe we can ask Jared, do you have any input on how to do that?
Yeah, so the common way of doing inheritance in a MongoDB collection is to use the sort of single table inheritance kind of paradigm where you would store a type attribute inside of a document and serialize and deserialize into the appropriate classes in your code based on that type attribute.
And we're taking a few more questions. There are a lot of questions. We're not going to be able to answer all of them here online. So what I've created a forum post on the Spring Source NoSQL forum, and if you look at the screen, you see the last link on that page. It shows you the link to the Spring Source forums. So the NoSQL forum there will have a post where we can post all the questions and post all the answers, and we can continue discussion over there. So we'll take a few more questions, and then please go over there and look for additional questions. So the question right now, the last one here we see, can we use MongoDB for storing millions of documents which are in XML format or PDF format? Can you take that one, Jared?
I'm sorry, I was just going through the Q&A in the chat. Could you repeat the question?
Yeah, can we use MongoDB for storing millions of documents which are in XML format or PDF format?
Yes, you can. So MongoDB's native format is JSON. And so you would need to fit that data into the JSON model. But one of the common approaches is to use like a field in the document that's like XML data, and to store the XML data as a string. Now, that will actually store the data in the database, but obviously MongoDB doesn't understand XML, so you would need to pull fields out of the document into the JSON structure if you want to be able to query or filter on them. As for PDFs, there's another question about that I was just answering actually about storing binary data. So there is a binary data type that you can use to store data inside of a MongoDB document. So you can embed that right inside of a JSON document. We also have a thing called GridFS, which is like an API on top of MongoDB that presents a file system abstraction and enables you to sort of store and load files out of Mongo.
Okay. Now I think we're coming to a close of this webinar. I just want to mention that the recording will be available early next week, hopefully on Monday. And they'll also be available on YouTube probably towards the end of next week. And I'd like to thank you all for attending this webinar. Hope you learned something, and we definitely learned a lot by putting this presentation together. Thank you all for attending.